Ladies and gentlemen, I'm very glad to share our work in few minutes. I'm Moon Liu, an engineer in state-grade Shandong Electric Power Research Institute. The main work of this paper focused on the recognition of transformer high-frequency partial discharge based on time domain feature. Power transformer is the most basic and core equipment of the power system. The transformer's insulation degradation will rapidly develop into a fault and cause a large-scale blackout and serious damage of the production and life. Therefore, it is very important to monitor the insulation status of a transformer. Partial discharge is an important reference for the insulation performance of a transformer. The recognition of the partial discharge types helps to assess the form and degree of the transformer insulation deterioration, find hidden dangers in time, and avoid transformer failures. The monitoring types of transformer partial discharge mainly include ultrasonic, ultra-high frequency, electrochemical, and high frequency, and so on. Researchers have studied in the field of partial discharge recognition for many years and have proposed many methods, including support vector machine, artificial neural network, random forest, deep learning, and so on. Transformer partial discharge signal is collected using the system shown in the figure. The partial discharge devices are deployed inside the transformer, and the high-frequency sensors are developed at the transformer's ground one to couple the high-frequency pulse signal. The real-time waveform and synchronous voltage signals are collected by the oscilloscope. A high-frequency partial discharge sensor adopts TWHCT 7850 with the 3 MHz to 30 MHz frequency band, and the oscilloscope is RNS-RTO 2044. And the structures of four types of partial discharge are shown in the left figure. The signal collected by the oscilloscope is shown in the right figure. It can be seen from the figure that the noise has a great influence. In order to reduce the noise influence, the wavelet transform is used. Wavelet transform is an effective transform analysis method which can find the high frequency and low frequency of the signal through the explanation and translation operation. The W5 wavelet with orthogonality and time support is used here. As a space, this wavelet is not easy to produce large smooth errors. That is, the reconstructed signal is smoother. After the signal pre-processing, a deep learning network is built for partial discharge recognition. Using supervised learning methods, a convolutional neural network is constructed to extract signal features. The first layer is convolutional layer, and the convolutional kernel is 1 multiplied 3 array. The step length is 1 and the channels is 64. The input is the pre-processed and enhanced signal. Then the output after passing through the first convolutional layer is as a formula 1. The activation function used is the rectified linear units function as the formula 2. The second layer is a polling layer using the maximum polling method. The polling window size is 1 multiplied 3 and the step size is 2. The third layer is the local response normalized layer using the concept of lateral inhibition in neurobiology. The calculation method of the local response normalization is as the formula 3. The output at this layer is expressed as the formula 4. Then the next connected layers is the second set of convolutional layer, polling layer, and the local normalized layer. The output can be expressed as the formula 5. Through these convolutional layers and related layers, the features in the original data can be extracted. The two fully connected layers are then connected to achieve a linear transformation from one feature space to another feature space, as the formula states. The last part of the network structure is the fully connected layers and the softmax layers, and the output is expressed as the formula 7. The softmax layer uses a multi-classes logistic regression method, which can convert the input to a probability of 0 to 1, that is, to achieve the conversion of features and probabilities. The calculation formula is expressed as the formula 8. After the construction of the entire network, a cost function needs to be defined to measure the difference between the predicted classification and the true classification. Cross entropy is used as the method to measure this difference, which can be expressed as the formula 9. In order to increase the generalization ability of the network and prevent overfitting on the basis of formula 9, an L2 regularization term is added, and the cost function is finally expressed as the formula 10. The stochastic gradient descent method is adopted as training method. Each iteration of the stochastic gradient descent method uses a set of samples and then updates the parameters according to the gradient. The batch size of each training set is 128 samples. Through the above processing and settings, the entire network can be tuned to a suitable state on the train set, and the feature extraction and classification recognition can be realized. There are 4 types of partial discharge to recognize: oil gap defect, fluid defect, tip defect, and surface defect. For each type, 200 samples are used to form the training set, and 50 samples are used to form the test set. Therefore, the total training set have 800 samples, and the test set has 200 samples. Network training is carried out through the training set, and the results are verified on the test set. A partial discharge recognition method was introduced in this paper. 4 kinds of partial discharge signals were collected through a high voltage partial discharge device and high frequency current sensors. We used the wavelet transform to remove interference of the time domain signal, and convolutional neural network were used to extract features and recognition. The accuracy of recognition is 91.8%, compared with deep neural network and OSELM algorithms. Our methods get higher accuracy. And this is the reference. Thank you.